did it for a good reason. This was a modified version of a study that was conducted at Yale University. This is kind of older now, but it made a really important point. And so I want to use this actual experiment that was done, and we're also going to look at our own results and see how that compares with what they found. Each of the resumes that you guys evaluated yesterday was 100% identical, except for one piece. And that was the name of the applicant. One of them was John Miller, and the other one was Jennifer Miller. But other than that, everything on the resume was 100% identical. So I'm curious, and what we were looking at here was whether or not the name alone was enough to influence your class's hireability estimates for these teacher candidates. So these are the ratings that I recorded off of the pages that you guys turned in no particular order. It's literally, I turned the pages over and I recorded the scores. So go ahead and get that copied into your own, and then I want to know the mean rating for John and the mean rating for Jennifer. So there were 10 papers turned in for John, 11 turned in for John and 10 for Jennifer. So after you add John's together, you'll divide by 11, and for Jen, you'll divide by 10. Does anybody have the mean for John? 5.18. And for Jen? 5.1. For a difference of what? 0.08. So 5.18 minus 5.1. Get 0.08 approximately. So, curious. Is the difference between those, that 0.08, there is a difference between these two. Is it statistically significant? Is it important enough to pay attention to? So it feels like the gut reaction in the room is probably not. How could we know whether it's statistically significant? Because like it is a really small value, and so I want to say no, but sometimes those little pieces over time mean that one individual is consistently getting, granted not much, but a bit of an advantage. Or is this just due to chance? Is this something that we would see happen over and over and over to where you'd be like, okay, this adds up over time? Or is this just kind of luck of the draw? So in order to determine how significant these results are, we're going to run a simulation. So what I did for this simulation, every single score here, all the ratings for John and ratings for Jennifer, I wrote down on little half index cards. So every single one of those 21 ratings. I put them on index cards in no particular order. You guys still need to get them and shuffle them. And you're going to deal them out into two piles randomly. One pile for Jen, one pile for John. And then we're going to record what you got from your simulation. So what we're looking at is if this difference was purely by chance. That's what we're trying to evaluate here. And we're going to do that by taking the scores that were actually given and randomly assigning them to these two people. And then seeing what the difference in the means is there. All right? So I only had enough time to make up 11 sets of index cards. So you'll have to find a partner. You'll share the cards with them, but you're not going to record the same numbers. So one person's going to mix them up, deal them out, record their numbers for Jen and John, and then the other person will take the cards, mix them up, deal them into two piles. All right? Decide ahead of time which pile is Jen, which pile is John, and then deal them out. One of them is going to have 10 ratings. The other one's going to have 11. That's okay. All right? Do you guys understand what I want you to do with the cards? Okay. So I'm going to pass these around. If you don't have somebody sitting next to you that you can share with, I'll try to partner some people up. Again, you're not sharing numbers. You're just sharing cards. All right? And then after you have your simulated ratings for Jen and John, you're going to do just what we did up above. You're going to find the mean for John, the mean for Jen, and you're going to subtract those two. So you guys will share that back. Make sure you mix them up really good. They should be small enough that you can kind of do that. Justin, why don't you hop up here so that you two can share that? You two can share that here. Why don't you share with Carolyn? You guys to share. So you want to take the paper clip off, mix them up really good. Whether you actually try to like formally shuffle or just mix them around on the table. And then you want to separate them into two piles. Decide which one is the Jen pile and which one is the John pile. One pile is going to have 11, one pile is going to have 12. Yeah. And then whoever you get, like for the first deal, that'll be for one of you guys, and then the other person will mix them up and do it again. And write it down on their paper. So as soon as one person has their simulated Jen and John data, make sure you give the cards to the other person. They will need to mix the cards up all over again and separate them out into two piles. You and your partner should not have the same things in the Jen and John rows. get yours written down? So which one is Jen, which one is John? Okay, so you're going to take all these numbers and write them down here. And then it'll be the same thing for John. You might want to set them off to the side so you know you've got them done. There you go. Yeah, that's absolutely correct. Because we want to make sure that we end up with 22 individual values so that if I'm going to bring around stickers, we're going to make a dot plot again. No, you don't just record the same values up here. That's your dot pile?
Nah, this is 11.
And that's okay. They're going to be different. Is this John or Jen? Okay, so if this is John, yeah, erase that, and then you'll record these values. There you go. Do you want to record those numbers down here? She's waiting on all the cards before she can get that. You and your partner should have different values written down. The only thing that you're sharing is the deck. I just didn't have enough time to make up decks for everybody. You guys are different on all of these? Those numbers look the same. No. One person deals, they get John and Jen. And the other person takes the cards, mixes them up, separates them. So you're going to have a completely different set of numbers. You're just sharing these. Sorry. No, you can keep that. Yeah. You and your partner should not have the same values for Jen and John. The only thing you're sharing is the deck of cards. One of them is going to have 11, the other one's going to have 12. So for those of you that have finished separating, and you have the numbers written down for the ratings for Jen, the ratings for John, find the mean for John and the mean for Jen. Find the mean for John and the mean for Jen. Are you guys done with yours? I'm going to go ahead and do it too so I can demonstrate up here. Let's see, I need some room. There we go. All right, so my own simulated data here. I have 4 and 6 and 6 and 6 and 7 and 4 and 5, 3, 7, 5 and 5. And for Jen, I got 6 and 5, 4 and 5, 5, 4, 5, 6, 5 and 5. All right. So you want to find your mean, and then after you find the mean, you are going to subtract those means. I lost my stickers. Where did they go? I'm going to bring everybody a dot sticker. Here they are. I want the difference of the two means. So you're going to do John minus Jen. You might get a negative number. That's okay. So you want to find X bar for John. You want to find X bar for Jen. And then you're going to subtract those two. You're going to do John minus Jen. Whatever that difference is, you're going to take your dot, you're going to put it on the poster over here that says what's in a name, John minus Jen. Whatever the difference in those scores is, you want to put the dot at that spot. Here's a dot sticker for everybody. Here's a dot sticker. Dot stickers. Again, we're doing it on the blue poster. Is it possible to get the same thing for both? Yes, it is. And then your difference would be 0, and you'd put it on there. Yep. All right, so when I ran my own simulation, I got 5.27 for John and 5 for Jen. So when I did my own here, you would write down whatever yours was. Obviously, mine is going to be different than yours. All right, so looking at the dot plot that we just made, I want you guys to sketch that dot plot. Don't write down my subtraction, write down whatever yours was. Whatever your mean for John was minus your mean for Jen. And then I want you to sketch the dot plot that we made on the board over here into your notes. All right, so I've added the dot plot up on the board, so you can either look to the side or you can look up at the front. What do each one of those dots represent? Yes. So what we did here, this is one simulation. And the difference in mean ratings for John minus Jen. Specifically, we had random assignment. So what we're looking at here, what we're trying to look at here, is whether or not this difference that we saw from running the experiment was just due to chance. So to test to see if it's due to chance, we took everybody's ratings and mixed them up and reassigned them using random assignment. And then we calculated those mean differences again. Do you guys remember from the very beginning with the actual scores you guys gave these people, what was the difference between them? 0.08. So I'm going to go ahead and mark that on here. 0.08. That's what, like right about here? So 0.08. Those were our class results, or the results from our experiment. So what we're going to try to do is to figure out how rare that kind of a result would actually be. If something's going on, if there's some kind of bias coming into play here, the results that we see should be very different than just random luck or random chance. So I'm going to start with the results from the experiment that we did here, and we're going to count all the dots that are that or bigger. Since we fell on a dot, we're going to include that one. I don't know exactly what that number was. Let me come over here and see if they wrote it down. Nope. We're going to assume that because it's in between these that it's 0.08. Yes, sir?
Yeah, I got it. It was 0.08.
Oh, perfect. So we're going to include that. So any value that's the same as what we got from our class results from our experiment or larger. How many dots fit that category? 10. So 10 out of, I included a dot. We've got 22 people in the class, plus I put a dot in here. So 10 out of 23. What is that as a percent? 43%. So there's a 43% chance of getting a difference in means of 0.08 or more purely by chance. Does that strike you as being very rare? There's a 43% chance that something happens just by luck of the draw? No. All right, so I'm going to take that sentence that I just said. We're going to write that down underneath number 3. We got 43%. So there is a 43% chance. Actually, I'm going to start this assuming that gender didn't make a difference. Because when we randomly assign this, we're assuming that there is no bias going on because of name. Assuming gender does not affect the score. There is a 43% chance of getting a difference in means of 0.08 or larger purely by chance. So with that in mind, do you think that the difference in means that we saw had to do with the name, or it was just by chance? Grace and I agree with you, just by chance. 43% is, like if it's a 43% chance of rain outside, you're probably taking your umbrella. There's a good chance it won't rain. There's a good chance that it will rain. So this is probably purely by chance. In our simulation, a difference in means of 0.08 or more happened quite often. %43 of the time. At what point would it catch your attention and be like, whoa, there's something going on here? What kind of a percentage would catch your attention? Very low percentage. So to kind of intuitively test this, I've got a Coke. For the first person that can pull randomly a black card from this deck of cards. I'm going to mix them up. If you pull the first black card, you can have the Coke. All right, I'm going to give them one more shuffle for good measure. All right. Josh, let's see if you get the Coke. What'd you get?
A 4.
4. A red 4. Okay. You also knocked out a queen of diamonds, so you got a 2 for there. Don't. Let's see if you can get the Coke. Discarded card. Seven of diamonds. No Coke. Xavier, you want to try for Coke? Get the black card, you get my Coke. 5 diamonds. Jamia. Two hearts. We're not doing so hot. Just need a black card. All you need is, you got a 50-50 shot, right? The winning card. Ace of diamonds. Is anybody gonna get my Coke? Ooh, what'd you say?
It's no black card.
Why do you think that? It's a bottom card.
I didn't see the black card.
At what point did you guys become suspicious there were no black cards in here?
Nobody got it. After I
So it turns out that people start to become suspicious when something happens only about 5% of the time. That's usually when that sends off alarm bells. It took us a little bit longer in here because y'all trust me too much. I'm gonna go ahead and collect my all red cards. No hope. At least not today. Not today. Higher, yeah, it's two red sets put together. So our threshold for when we start to say, this doesn't feel just purely by chance, hovers right around 5%. So that's the cutoff that we're going to use in here. So if something happens less than 5% of the time, that's when we're going to say, I don't think this was by chance. I think there's a cause and effect going on here. I think there's something more. All right, so if the percent is less than 5%, that's when we will call it statistically significant. If our percentage is more than 5%, it is not statistically significant. In the original Yale study, these are the actual results. The applications were sent to a STEM facility at various different universities for an open lab manager position. So each of these different universities' labs were only sent one resume. And among the 127 faculty that were randomly assigned either Jen or John, the mean hireability rating for John was 3.78. And the mean hireability rating for Jen was 2.93. So what was their mean difference when this study was actually conducted and they were looking to fill a lab manager position here? 0.85. 3.78 minus 2.93. You said 0.85? I want to look over at our simulated dot plot here, because they were given the same rating, 0 through 7 on hireability. Where does 0.85 fall on here? Like right over here. So maybe 1 out of 23. Does that strike you that there might have been something going on? That is a rare enough occurrence that it's probably not just by chance. So do you think that provides more or less convincing evidence of gender bias in filling a lab manager position? More evidence here. 0.85. We had 1 out of 23. What is 1 out of 23 as a percent? 4%. So this is more convincing evidence. Because that would be quite rare. to just happen by chance. Does it mean that it couldn't happen by chance? No. It is possible that it happened by chance. It's just not very likely that it happened by chance. This is the importance of repeating experiments. So when somebody has come out with this groundbreaking experiment, they're like, look at these results. This is astounding. It needs to be repeatable, and it needs to be just as surprising again. Otherwise, it probably did just happen by chance. All right. Let's get our big ideas. Sorry, I had another activity planned for us, but we don't have time. So one of the things that I definitely want to talk about here, and that I forgot to mention when we were looking at the Yale study, they had a much larger sampling pool. We only had 23 pieces of sample data. They had 127. Different samples are going to yield different estimates. That's not surprising. Larger samples are going to produce more accurate estimates. They're going to decrease the variability. They're going to make it easier to determine statistical significance. Something that we didn't really touch on much, and we'll talk about how to calculate later, is this idea of a margin of error. Margin of error tells me, oh, we could be off a little bit. Here's about how much we think we're off by. So our sample estimate plus or minus a margin of error. We refer to something as statistically significant when the results are too unusual to have just occurred purely by chance. Assuming that it occurred purely by chance, if we see the results that we found in our experiment happen less than 5% of the time when it is just purely by chance, that's when it catches our attention. More than 5% of the time, you're like, meh, it's very likely this was just chance. This copied down, I do want you guys to try the check for understanding, whatever little bit of time you've got left. Only I want you to do the check for understanding on page 25. We'll come and look at the one that's on page 27 later. So I want you to go back to the one that's on page 25 for today. Yes. Yes. Just one moment. Right over here. treatments are the conditions that your experimental units are actually exposed to. So in that particular study, how many things were they looking at? So those would be your factors, okay? And then your treatments, we have to look at all the possible things that your experimental units will be exposed to. So jazz music with a recording message, jazz music without a recording message. So you want to list out all the possible things. For your factors, is what are all the variables there? Go ahead and list them out. I want to say that you're not controlling for it, and then the treatments would be things that are the actual conditions that we're supposed to do. I have been for a long time. My sister, so she is over the moon excited. So tomorrow, I want to keep looking at this idea right here because this is not only really important, it's also a little bit difficult to wrap your head around. So I want to do another simulation tomorrow, looking at the same types of things. That does mean, though, that I'm going to end up bumping our test a little bit. So originally we had it set for Wednesday, which would still be the perfect day. We had to bump it up to Tuesday, though, because I won't see you guys on next Wednesday because of PSAT testing. So I'm going to bump it to Thursday. I think that'll give us the right amount of review time and still let us do this experiential thing where I think we're going to get more out of it than just adding in an extra review day. All right? Have a great one, everybody.